To understand the movement of the bodies in this universe, three laws are essential. The three laws were given by Sir Isaac Newton. Among the three laws, the third law is very famous one. That is called Newton's third law of motion. Now we are going to learn about the statement of the Newton's third law. The statement, it goes on like that. For every action, there is an equal and opposite reaction. Here, action means a kind of force which is acting on the body. Immediately, the body also exerts equal and opposite force. So, action is a kind of force, reaction is also another kind of force. Both of them, magnitude wise, they are equal and they will be acting opposite to each other. So, as soon as the action acts on the body, immediately at the same instant, the opposite force, that opposite reaction acts on the other body. So, this is called as action-reaction pair. Look at the mathematical form. F12. What is F12? Force acting on the first body due to the second body. That is equal to, magnitude wise it is equal to force acting on the second body due to the first body. Here vectorially it is represented. That negative sign, it shows that the direction of the forces acting on each body are opposite in nature. The following points must be remembered while learning Newton's third law. Always the action and reaction forces, they will act as a pair. A single isolated force cannot exist in nature. The action force and reaction force, they won't act on the same body. They act on two different bodies. One of the forces can be called as action, the other force can be called as reaction. This Newton's law is valid both in inertial as well as in non-inertial frame of reference. These action and reaction forces, they are not cause and effect forces. In the case of Joule's law of heating, when current is passing through the wire, that current passes through the wire can be called as cause. But the production of heat in the wire can be taken as effect. Here, there is a time difference between the passage of the current and the production of heat. But in the case of Newton's law, there is no time difference or lag between the action and reactional forces. Both action force and reaction force, both are cast at the same instant of time. It means that when object 1 exerts force on the second object, and the object 2 exerts an equal and opposite force on the body 1 at the same instant. Here 4 examples are shown to understand the Newton's third law. In the first example, a book is placed on the table. The book is attracted by the gravity. So because of that, the book exerts force on the table. That can be taken as action. The table also applies equal and opposite force on the book. That is a normal force which is acting towards upward direction. The force exerted by the book on the table and the force exerted by the table on the book, both are acting in the opposite direction and both of them are acting at the same instant. So the force acted by the book on the table can be taken as action. The normal force exerted on the book by the table can be taken as reaction. The second one, this is about our walking. Here we are able to walk only with the help of the phenomena called Newton's third law. When we push the ground with the help of our foot, that backward force can be taken as action. The ground also applies a equal and opposite force on the foot. That is called reaction. So with the help of action and reaction forces, we are able to walk. In the third illustration, the propulsion of the rocket. So the fuel that creates enormous amount of pressure and force at the bottom of the system of the rocket that can be taken as action. There will be a upward thrust that is acting at the top of the rocket. That is called reaction. So because of the action and reaction pair alone, the rocket is able to propel. Look at the last example. That hammer, it applies force on the nail. That can be taken as action. As soon as the hammer it is in contact with the nail, nail also applies equal and opposite force in the opposite direction. That is called as reaction. The force applied by the nail can be taken as action, and the nail also applies a force on the hammer is called reaction. Here both are acting as a pair. Here the actional force is acting on the nail, the reactional force acting on the hammer. This is one of the activities given in your textbook. This activity is based on Newton's third law of motion. Look at the arrangement. The first spring balance that is connected with attached with the wall support. The free end of the first spring balance that is connected with the second spring balance. The free end of the second spring balance, it is attached with a rope. That rope is allowed to pass through a pulley. Here a mass is attached in the string. Let us say 500 gram is attached. Here look at the reading in both the two spring balances. The first spring balance, it applies 5 Newton amount of force on the second spring balance. Second spring balance also applies equal and opposite 5 Newton amount of force on the first spring balance. If you increase the weight in the hanger, automatically the force applied on each other will be increasing, but they will be equal. Look at the first reading. Spring balance shows the actional force of 5 Newton. Spring balance 1 shows the actional force of 5 Newton. Spring balance 2 shows the reactional force of 5 Newton. Okay. If the weight is increased, let us say the second reading you are able to observe 9.92 Newton as the actional force, which is shown by the spring balance 1. The equal and opposite force of 9.92 Newton is shown by the spring balance 2. So it shows that they are exerting equal and opposite force on each other. Both the readings are shown simultaneously at the same instant. It shows that action and reaction both can be taken as a pair.